All right. The steel ingot has a mass of 1800 kilograms. It travels along the conveyor at a velocity v equal to 0.5 meter per second. When it collides with the nested spring assembly, if the stiffness of the outer spring is Ki equal to 5 kilonewton per meter, determine the required stiffness Kb of the inner spring so that the motion of the ingot is stopped at the moment the front C of the ingot is 0.3 meters from the wall. Okay. There are two springs here. They're all getting compressed one inside the other. So the ingot comes and compresses the two to a maximum extent like this and stops. So at that stage, it says the distance from the wall is 0.3 meters. So if you carefully observe, the outer spring A, the original length is 0.5. So we can say the displacement of XA equal to, from 0.5, it is compressed to 0.3. So the displacement is 0.2 meters. And XB, the original length is 0.45 meters, and it is compressed to 0.3, which means 0.15 meters is the compression. And the velocity of the ingot when it strikes the spring assembly is 0.5 meter per second. The spring constant of spring A equal to 5,000 Newton per meter, and the spring constant B is not known. From the time it hits the spring assembly to the point it stops, if you call this as 1 and this is 0.2, and equation of motion T1 plus sum of all the works done by external forces, AC2. The initial kinetic energy of the mass is, what is the mass? 1800 kilograms. Times 0.5 square plus the work done by the spring forces. As you can see, if you take the free body diagram, the weight, the reaction, no friction is given, so forget it. There will be two spring forces opposite. One is spring A and the other one is spring B. Therefore, it is the work done by the first spring force is half Ka, which is 5,000 times the displacement of it is 0.2 half kx squared 0.2 square. However, it is against the direction of motion because the block is moving to the left. And so we need to take this work as negative. And also the work done by the second spring is half. We don't know the spring constant Kb, but we know the displacement 0.15 square. In this equation, we need to equate it to the kinetic energy at the end. But because the block is stopping, it is 0. Solve this equation, get Kb as 1100 100 Newton per meter. Therefore, Kb equal to 11.1 kilonewton per meter. Okay, I'm happy to answer any questions. I'm just waiting here. Type the questions in the chat area. There are 119 students now, so it's clearly working.
Minimize this. Increase more space.
Any question? Okay, I'll go to the next one. Consider this as important. Can you clearly hear what I'm saying? One or two people can just say yes. Okay, great. Yeah, that's okay. Okay, source. What is the problem? Type it. Malaki, I'm allowing you to talk if you want. I can't hear anything. Yeah, I can't hear. So just type if you have any question. Okay. The 0.5 kilogram ball is fired up the smooth vertical circular track using the spring plunger. The plunger keeps the spring compressed 0.08 meter when S equal to 0. Determine how far S, that means the distance. It must be pulled back and released so that the ball will begin to leave the track when theta equal to 135 degrees. Okay, it's a very tricky problem, but if you know how to solve it, you can solve. If you don't know how to solve it, you can't solve it. Okay, first things first, this ball is here. It's hit by the spring and it starts climbing the circular track, and gradually it loses velocity. And what he says is, when it comes to point B, it is just about to leave the track. When will that happen? When the total normal reaction is 0 and it is only supporting the circular motion based on the weight component towards the center. So let's draw the free body diagram of B, or the ball at B. Say this is the ball, its weight okay, let me use a different color for this. X vertically downwards, and we take the normal direction like this, and the tangential direction like this. As you can see, the total angle here is 135. So if this 90 is subtracted, this is 45 degrees. That means this is 45 degrees. And there will be a normal reaction. But for the condition when the ball is just about to leave the track, the normal reaction is 0. So for that condition, if we use the equation sigma Fn equal to mass times the normal acceleration, the centripetal acceleration. If you apply that, this is only mg cos 45, which is the component of this mg in the normal direction. That is the one which is giving centripetal force. This must be equal to mass times the velocity of the ball at B squared divided by the radius. Now I can strike this mass out of it. Therefore, VB squared is equal to RG cos 45. Therefore, VP is square root of RG cos 45. Substitute these quantities. Root R is 1.5, 9.81 times cos 45. Velocity at B equal to 3.2257 meter per second. So using the condition that the ball is just about to leave the track at B, I could get what is the velocity of around the ball at B. Now, come back to the actual spring. The spring is compressed by an S displacement and it is released. And that energy or the work done by the spring is transferred into the ball and the ball climbs up the track. Between the starting point where we are releasing the spring and the point where the ball is at B, from A to B, equation of motion, no, sorry, work energy equation. We can say TA plus sum of the external work equal to TB. At the start, everything is static. So the velocity is 0, TA is 0. And the spring is actually pushing the ball. So the spring is doing work on the ball. So the spring energy must be taken as positive. Now, let's say the spring is compressed by an S distance. What he says here is, if you release this when S equal to 0, the spring has a residual compression 0.08. That means in the cage, it's already compressed by 0.08. We are adding an S displacement to this 0.08. What it means is we are pulling it by S plus 0.08. So the energy released when you release the spring is half K, which is 500, times the total displacement is S plus 0.08 square. This whole energy would have gone into the ball if the spring is coming back to 0 displacement. However, as it is confined into the spring cage, it will still have a 0.08 residual displacement. So that energy will not come out. So minus half 500 times 0.08 square. This energy is residual in the spring because the spring remains in the cage with that much of displacement. So the energy that is coming out is only the difference between the two. And then the ball is climbing up. So it is doing negative work due to gravity. So to what extent it is going? If you look at the picture, from this height to this height, it is going. That is the height through which it is climbing. In that part, this is the radius, which is 1.5, plus this length is equal to this, which is, this angle is 45. So we can write this as the radius times sine 45. So the work done by the ball as it is climbing up is mass times g is the weight times the height. Mass is 0.5 times g is 9.81 times the height through which it is going is 1.5 plus 1.5 sine 45 is equal to half times 0.5 times 3.2257 square. This is the kinetic energy it is possessing when it is at B, half mv square, where v is the velocity at B. Now that equation, if you can write, you can solve the problem. You can expand this and simplify. You will get an equation like this: 250 s square plus 40 s minus 15.16 equal to 0. So it's a quadratic equation you can solve and get s equal to 0.1789 meter. Okay, ready to answer any questions. So 126 students. So there are 120. Okay, ys plus 0.08. Okay, let me. The spring is confined in this cage. If you make S0, the spring will still be compressed by 0.08. That means it's not coming back to its original length. So what are we doing? We have a spring in the cage which has a displacement, say 0.08 meter. Now you're compressing it by an s distance. So at this location, the displacement in the spring is S plus that initial compression. Now the energy released is K times x2 square when you release that spring. However, all this energy will not come out because spring eventually will rest with that residual displacement. So minus half K times 0.08 square will be still in the spring. It will not come out. That's the reason why. Now, what else? What is the external forces? What do you mean by external forces? The spring force here, and we consider that. What does T actually stand for? T is the kinetic energy. Were you present in the class, sir? I taught the work energy equation. The UAB is what I think. UAB is the sum of the works done by all the external forces. So, Michael, I told the T1 and the T2 are the kinetic energies at the start and at the end. Yes, the equation sheet will be given as was given last test. How did you get 40S? What is 40S here? No, you just expand S plus 0.08 whole squared. It becomes S squared plus 2 times S times 0.08 plus 0.08 squared, and multiply it with the whole of it, and then simplify. You will get that. I didn't do all that. I'm leaving that for you to do. And any other question? So can we recon plus mgh on the right side of the equation? What do you mean? You want to put it on the right side? The ball on its own will not do any work. So work is done on the ball always. However, some of those works help it to move and some don't help. In this case, the spring pressure is pushing, so it is helping it to move. So we are taking that work as positive. The gravity force is pulling it down, but the ball is trying to move up. So that mgh, which is the work done by the gravity force, the weight, is considered as negative. I think it would be easier to find EA equal to EB. What is EA? A work energy equation is not just energy, because you are talking about the principle of conservation of energy that is applied in only specific cases. We will come to that later on. What is the total height? I showed you this is the total height, which is this part plus this extra part, which is this. (1.5 sine 45), that is this part. In this triangle, This height divided by the radius is sine 45. Therefore, this part is 1.5 sine 45. Any other question? Okay, if you don't have any questions, I'll go to the next question. Consider this problem also as very, very important. The skier starts from rest at A and travels down the ramp. If friction and air resistance can be neglected, determine his speed VB when he reaches point B. That's where it is. Also, find the distance S to where he strikes the ground at C. If he makes the jump traveling horizontally at B, neglect the skier's size. He has a mass of 70 kilograms. This problem has two parts. The first part is the sliding from A to B. The second part is the jump from B to C. We can use the equation of motion, the work energy equation from A to B, and from B to C, we will use the methods we learned while solving projectile motion problems. A to B, work energy equation. TA plus the sum of the external forces is TB. At the start, the skier was starting from zero velocity. So kinetic energy is 0 plus what is the external work done? He is moving down by a height carefully A to B that is the height, which is this 50 minus this 4, which is only 46 meter. And so when a mass equal to 70 kilograms is moving down by 46 meter, the work done is mgh, which is 70 times 9.8 times the height through which he is falling is 46. This is positive because the weight force direction and the movement direction, which is downward, all the same, equal to his kinetic energy at B, which is half 70 times velocity V square. It's only the VB that is unknown. Therefore, VB equal to 30.04 meter per second. So we now calculated the velocity at B relatively easily. Any question in this part? Why did you minus 4? What is that? Where is minus 4? TA is 0 because at A, he is starting with 0 velocity. So mv square is 0, half mv square. How do we know when to use the work and energy equation? You have to solve a number of problems as we are doing, and you need to pick up a pattern, and then you will realize itself. Because the ramp is 4 meters above B. Oh yeah, yes. This is there is a 4 meters height here, and that actual height through which he is falling from A to B is 50 minus 4. Any other very good. Let's try the rest of the problem. The rest of the problem we already solved because it is what is it? Projectile motion. Let's take it up here. Let me draw a simplified sketch. Say this is point B, and there is a vertical drop of 4 meters here, and after that it is going inclined like that, and this distance is R, and this angle is 30 degrees. And he is asking at what distance, yes, it will hit the slope. So this length is yes. Okay. Then this height as you can see, this is S sine 30. And this is 4 meters. At B, the velocity is given to be horizontal. He stated that in the problem. See, it's traveling horizontally at B. If he did not give it, then we would have to find out that direction also. Luckily, he gave it here. Then the horizontal direction, I'll slightly readjust them here. Here, I want space there. Okay. The horizontal motion the distance traveled r is equal to s cos 30. But this must be equal to the horizontal velocity pbx times t. We know the horizontal velocity at b, we calculated that 30.04 times t. So from this, S is equal to 34.6895 t. So we are asked to find what is S. If we know t, we can get that. So how to get to t? We have already squeezed the horizontal motion sufficiently. We can't get anything there. So you need to consider the vertical motion or motion in the vertical direction. There was no vertical velocity at B. So VBY 0 equal to 0. And the total vertical drop H equal to S sine 30 plus that extra 4. Acceleration equal to, we can take an XY axis and define all these things with reference to that. For simplicity's sake, I'm considering downward motion as positive and just applying this equation in the downward direction. What is that equation? S minus S0 is V0t plus half AC t squared. And this S minus S0 is the total height traveled downwards. S sine 30 plus 4 equal to, in the y direction, V0 is 0, so 0 plus half 9.81 times t squared. Remember, I took the downward direction as positive and just apply that equation as the particle is moving downwards. So if you solve this, you will get another expression for S, or I will substitute what is T here, S over 34.6895. Therefore, S sine 30 plus 4 is equal to half 9.81 times, instead of T, I'm substituting T equal to S divided by 34.6895. And this S is the only unknown. We can solve for it. S is equal to 130 meters. Can you tell me if you have any problems? Any questions? If you want to ask questions, I don't understand the horizontal motion equation. Horizontal motion is the distance traveled with uniform velocity. Distance moved equal to uniform velocity times t. And so that velocity we calculated as 30.04, and r is the total distance it traveled in the horizontal direction, which is s cos 30. So s cos 30 equal to 30.04 times whatever time it is flying. Displacement equal to velocity times t. Okay. Why is it s sine 30 plus 4? As I drew here, this part is yes, and this is 30 degrees, and so this is s sine 30 plus there is an extra 4. So the total distance it's traveling vertically downwards is s sine 30 plus 4. The question said that the motion at v was only horizontal. Yeah, that's why we're taking vb acting in the horizontal direction. How do you know that vby? Yeah, as I said in the question, he said at v the particle is moving in the horizontal direction. Beatrice, Mino, Barreto, etc. I didn't see that. Oh, okay. Oscar. So for direction, we need to use what we know from before, but if direction is not needed, then we can use energy right. Okay. Okay. Do you want to speak out, sir? I'm a bit confused. If you raise your hand, I can allow your mic if you have. Oscar. If you want to talk, I will. Raise the hand. Don't have a mic, sorry, but if direction is not needed, then we can use work energy. No, 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 no. Um, no, you cannot simplify it like that. In the case of this projectile motion, you can still apply the energy equation. What it will give you is, for example, between B to C, if you apply the energy equation, it will give you what is the velocity of striking at C. But that velocity is not in the horizontal direction, in the vertical direction. So it will give you some velocity. You need to resolve that into components again. But then it doesn't help you to calculate what is the distance s. You will have to come back to the kinematic equations, because distance is s equal to v0t plus half act square. If you don't use it, you can't get that distance. That's the problem. is the velocity we are trying to find a scalar or velocity is actually vector, but when you calculate it from the work energy equation, it actually gives you the magnitude. Velocity is always a scalar, but you can calculate the magnitude, and if that solves the problem, it solves. But if you're after quantities like this, the velocity is not going to help you. We need to use the kinematic equation like this. So the problem is there are only few equations. Depending on the situation, you need to decide which equations and in what order take you to the final answer. As I said many times, at times it gets complex. The only solution is streamline all these thoughts and get experience from the problems we are solving. Keep the right things at the right place. That is the exercise needed. I'm only trying to get that into your brains. Okay, any other question? Will the kinematic equations be given to us for the test? I gave a test, the equation sheet last time, and it is also uploaded on Blackboard. It's the same one. Let me see what it is, because I don't remember what equations there are. Okay, go in my... Yep, the kinematic equations are there. Yep, any other question? $133 students are there, but quite a few are still not there. Okay, that brings us to the end of the tutorial problems. I will now start Okay, for now I'm closing this. Could you please upload the tutorial streams after the session? Yes, I will do that, ma'am. The solved version I will upload. The unsolved version is already there. Yeah, I will upload it immediately after the session. Or if you want, I can do it now, but that will waste some of our time. Okay. Consider this as another important problem. If you know how to solve it, you can solve it. If you don't know how to solve it, you will die. So be careful. Okay, if the truck travels at a constant speed of Vt equal to 1.8 meter per second, that's what it is doing here. It's a simple problem, but gets complex. Determine the speed of the crate for any angle theta of the rope. The rope has a length of 30 meters and passes over a pulley of negligible size at A. I'm sorry, I'm talking with breaks. The problem is it's taking a few seconds for me to listen to what I'm saying. So that's the problem. Okay. In all these connected problems, look at the length of the rope and develop the equation for the length. And after that, if you differentiate, you will get the relationships for velocities and displacements. What is the length of the rope here? Now, there are two particles moving here, connected. So first is the truck, and we are measuring the displacement of that as, say, xt, that is xt. And particle C, or the crate, we are measuring is xc. As the truck is moving, xt increases, xc decreases. And the total length, which is this length plus this length, that remains the same. And that length is given as 30 meters. This is the trick. However, the velocities are not going to be directly related. Though the length, for example, if you have one car and another car connected by a rope of 30 meters, and if this is moving with a velocity v, this will also move with velocity v. There is no reason why they don't. The problem here is this angle. Because of that angle, as xt changes, the position of b changes, and so that angle keeps on increasing. When the angle increases, it's dangerous. So what you need to do, in terms of xc, and this height is constant, 6 meters. So what is the length of this part? Can we write it as root xc squared plus 6 squared using the Pythagoras? This diagonal length is under root 6 squared plus xc squared. And this plus whatever is xt, this must be equal to the total length of the rope. It's a simple equation. Therefore, xc squared plus 6 squared to the power 1/2 plus xt equal to 30. Differentiate both sides with reference to time. So what it will give you? I'm differentiating the left side with the time. So it will become half times the function time to the power half minus 1, which is minus half, times the differential of inside, which is 2 times xc. But because we are differentiating an x function with a t function, we need to write dx over dt, which is xc dot dxc over dt. This part is dx over dx, and this part is dx over dt, this part. So that this gets cancelled. What we are doing is dx over dt. So I told you this in the class. That is the most difficult part. And once that is done, the other side is dxt over dt is xt dot equal to, on the right side, constant. When you differentiate it, it is 0. Let me write it in a simplified way. Therefore, half 1 over root x squared plus 6 squared times 2xc times xc dot plus xt dot equal to 0. Xt dot is nothing but the velocity of the truck, which is given as 1.8 meter per second constant. And are you having connection problems? Because I do too. I cut out on that part for me. What part? Okay, let me repeat this again. Differentiating with reference to time. WRT means with respect to time. Okay. First, this part, the differentiation is half xc squared plus 6 squared to the power half minus 1, which is minus half, times d over dx of this part, which gives you 2xc, then dxc over dt. Let me write it here, dxc over dt plus dxt over dt equal to 0. So this means half 1 over xc squared plus 6 squared under root times 2xc times dxc over dt can be written as xc dot plus dxt over dt xt dot equal to 0. Then xc in this triangle, xc over 6 is tan theta. Therefore, xc, no, wait. Six over xc is tan theta. Therefore, xc is equal to 6 over tan theta. All right. Now we can substitute x t dot equal to the velocity of t equal to 1.8 meter per second. I'm substituting these quantities: half times 1 over square root of xc is 6 square over 10 square theta plus 6 square. I simply substituted xc equal to 6 over tan theta times 2 times xc, which is 6 over tan theta, times xc dot, the velocity of c, we don't know that, plus xt dot is 1.8 equal to 0. If you simplify this, what will happen? Half times 1 over 6 squared plus 10 squared theta. We can take LCM, 10 squared theta. At the top, it becomes 1 plus 10 squared theta divided by 10 squared theta. And that 6 also can be kicked out, common, 1 over 1 plus 10 squared theta divided by 10 squared theta under root. I simply took 6 square common, and when it goes out of the root, it becomes 6. And 1 over 10 squared theta plus 1 will be 1 plus 10 squared theta divided by 10 squared theta times 6 times 2 is 12 divided by tan theta times xc dot is nothing but the velocity of c plus 1.8 equal to 0. When you simplify this, it becomes this 10 squared theta can be taken out of the root. It goes to the numerator and gets cancelled with this. 1 plus 10 squared theta can be written as 1 plus sine squared theta divided by cos squared theta. And it becomes 1 cos squared theta plus sine squared theta divided by cos squared theta, which will become 1 over cos squared theta. So it becomes under root 1 over cos squared theta. And when it goes to the numerator, it becomes cos theta. Writing all this here for your convenience. What I have from the previous page is this is what we have. Can I write it as 1 over 12, or can you see this 2 times 6 is 12, and that 12 gets cancelled, and this is 1 divided by tan theta can be taken, oh, sorry, wait, 1 over tan theta times root 1 plus tan square theta times 12 is gone, 1 over tan theta times Vc plus 1.8 equal to 0. And that is equal to this tan theta can go upstairs, tan theta divided by root 1 plus tan square theta times 1 over tan theta times Vc plus 1.8 equal to 0. But this tan theta gets cancelled. This is equal to 1 over root 1 plus sine square theta. Tan theta is nothing but sine theta or cos theta. Sine square theta divided by cos square theta times Vc plus 1.8 equal to 0. But this can be written as 1 over root cos square theta plus sine square theta divided by cos square theta times Vc plus 1.8 equal to 0. That cos square theta plus sine square theta is 1. 1 over cos square theta under root, it becomes 1 over cos theta. Therefore, Vc over cos theta, no, Vc times cos theta, because 1 over cos theta in the denominator equal to minus 1.8. So which means Vc equal to minus 1.8 divided by cos theta. So the velocity of C is varying like this. As theta increases, the velocity will be changing. It's all mathematical exercise, but the most important thing is the first writing that expression for the length. If that is correct, and then this part is correct, you are almost there. And the rest is algebraic variations together with some trigonometry. Even if you make mistakes in the rest of it, you will still get a majority of marks. So any question? This question will not be there, but there may be a question similar to this. So it's important. Can you explain 1 plus sine 2 theta to cos 2 theta plus sine 2 theta? Why? I gave all that in the first intro that I gave. Go back and refer to that. The important trigonometric identities. So if you don't have any questions, I will move on. At the instant shown, car A is traveling with a velocity of 30 meters per second, which is here in this direction. Carefully follow this. At the same instant, B is traveling on the trumpet interchange curve, which is here, with a speed of 15 meters per second. So velocity of B is here, tangential to that curve, which is decreasing at 0.8 meter per second square. So acceleration of B, don't worry about the direction. The acceleration always put in the direction of the velocity, but if it is given as deceleration, take that as minus 0.8 meter per second square. And for all practical purposes, take that as positive, acting in the direction of velocity, but substitute negative quantities. Determine the relative velocity and the relative acceleration of B with respect to A at this instant. So when you face problems like this, write the velocities and accelerations as vectors, and everything falls in place. And where is the XY coordinate system? Let's choose, I don't know. Let's look what's happening here. Why is it negative? It's deceleration. We can fix the XY coordinates as anywhere. Let me put it here. With reference to this, we will define both velocity and acceleration of the two cars as vectors. Once you do that, no one can stop you from solving. Car A. Velocity of A is in the x direction. So this is equal to 30I. And he also said it is accelerating at 2 meters per second square here. So 2I that's done. Car B. Velocity of B is equal to, can you see the track is at 60 degrees there? And so it should be making 60 degrees with x-axis. And the magnitude is given as 15 meters per second. So this is 15 cos 60 I plus 15 sine 60 j. After simplification, the velocity of B is 7.5 I plus 12.9904 J. Acceleration of B. There is an important aspect you need to observe here. B is going through circular motion. It will have two accelerations. One is a normal and the other one is the tangential. And so we know the tangential. This is the tangential. So let us write it first. AB tangential is equal to minus 0.8 cos 60, that is the x component, I minus 0.8, losing space here, minus 0.8 sine 60 J. And after simplification, A, B tangential as a vector is equal to minus 0.4 I minus 0.6928 J. So that is the tangential acceleration, but the normal acceleration, we need to carefully do it. So let me draw the position of P. It is actually going through a circular path like that at that instant, and B is there, and we put the tangential acceleration AB tangential that way, and AB normal will act this way. So this is our normal axis. This is the tangential axis for that situation. We know this is 60 degrees. So then what this will be? 30 degrees. Therefore, AB, okay, by the way, what is the normal acceleration? Is the magnitude is V B tangential squared over the radius at that instant. It is a centripetal acceleration. So which is equal to 15 squared over rho, which is given as 250. So from that, the magnitude of AB normal 0.9 meter per second square. So come back to this, equal to 0.9 times cos 30 I, and because it's acting downwards, the y component should be taken as negative, minus 0.8 sine 30. Do you understand why it is negative? Because the y component of this will be this way, and the x component of this will be that way. And our positive x is this way, positive y is that way. So the y component is negative. When you simplify it, AB normal is equal to 0.7794 I minus 0.45 J. The total acceleration IB is AB tangential plus AB normal. So you just add the x parts and the y parts. AB equal to, I'm writing the final answer, 3794 I minus 1.1428 J. That is acceleration P. Acceleration A is this. Velocity of A is this. And the velocity of B is this one. I told you in the class, relative velocity, whenever you have two vectors, say velocity of A or velocity of B, if someone asks you what is the velocity of B with reference to A, you need to write the vector like this. This is velocity of B with reference to A. And I also told you when they are coming head on like this, VBA equal to VB minus VA. So in your case, he's asking you what is the velocity of B with reference to A. It is VB minus VA. Just subtract those two vectors. I'm getting minus 22.5 I plus 12.9904 J. And acceleration which is equal to minus 1.6206 I minus 1.1428. And if we want the magnitudes of these, therefore VBA magnitude is under root this squared plus this squared, which gives you and acceleration B with reference to A, just the magnitude is 1.983 meter per second square. That's it. Happy to answer any questions if you have. When you calculated ABN, why do we use VBT instead of VBA? There is no acceleration in the normal direction. When anything is going around a circular path or a curved path, it's only tangential acceleration. I'm sorry, tangential velocity. Velocity is only one component. If it has velocity towards the center, then it will be moving towards it. Can you show how to solve VBA, the last equation? In any vector, equal to under root x component square plus y component square. That gives you this. And similarly for acceleration. I'm not so worried about the units and things like that, as long as you are using consistent units. The main problem is mechanics and the use of equations and applying them in the right order. Any question? Any other question? No. I will solve as many as I can. This problem was already solved in the class. I just thought I will repeat some parts, but as your friend, what is his name, Mr. Bailey Kanan, is worried about the time, I will leave that for you. Don't blame me if this problem comes in the test on Friday. Blame Mr. Bailey Kanan. Look at this problem. Determine the required height h of the roller coaster so that when it is essentially at rest at the crest of the hill, it will reach a speed of 100 kilometers per hour when it comes to the bottom. Also, what should be the minimum radius of curvature rho for the track at B so that the passengers do not experience a normal force greater than 4 mg, which is 39.24 m, which is 4 times the normal gravity. Neglect the size of the car and the passenger. Okay. First, from A to B, let's apply. So, in problems like this, it's always better to use either work energy equation or the equations that we will get later on. For now, it's work energy equation. At A, the car was starting from rest. He said that. So there is no kinetic energy, 0. Plus, we are neglecting the friction. Nothing is stated about that. So it's equivalent to the car falling down by a height h. Therefore, the work done by the car during that process due to the weight is mg times h. This must be equal to the kinetic energy possessed at V. So the kinetic energy is half mvv squared. So we can cancel this m and m. Can we write vb or substitute the known quantities? Therefore, G 9.81 times the height h unknown equal to half. He's saying that velocity of B at B, velocity of B is given as 100 kilometer per hour. Let's convert that into meters per second, which will be 27.778 meter per second. Okay, so equal to half, mass is gone and velocity is wait, where am I? $27.778 square. From that, h is equal to 39.32 75 meters. That part is done. It's easy. Go to the next part. Also, what should be the minimum radius of curvature rho of the track at B so that the passengers do not experience a normal force greater than 4 mg? Let's draw the free body diagram of the car at B. It experiences a normal reaction from below, which is M. Its weight, W, acts downwards. And it is going through a circular path that will be the normal direction. And the tangential direction is this. And along the tangent, it will experience a velocity which is Vb. If you use sigma Fn equal to mass times An, which is the equation of motion along the normal axis, it gives n minus w equal to mass times normal acceleration is Vb squared over rho. The normal reaction, he's saying, is 4 times the weight, which is 4 times 9.81 times the mass minus m times 9.81. This weight is equal to m times the velocity is 27.778 square. Maybe there is another 7. Let me put that also. Divided by a rho. You can cancel this mass also. So the radius that is necessary is equal to 26.2184 meters. Tell me if that is fine. Okay. What is this? I really hope this question isn't in the test. What a shame that would be. What that question? So do not waste time and space for unnecessary talk. If you have question, you ask. Don't have question, you follow. If you know, you leave. So in the question said normal force greater than 4 mg. Is that means n equal to 4 mg? No, n equal to 4 mg. It should not be greater than 4 mg. Not greater than 4 times the weight. And so we are taking n equal to 4 times mg. M is for the mass, yes. Yeah, 39.24 times the mass is the normal force. 39.24 is 4 times 9.81. Zach Bailey, what is the problem? Can you explain how you expanded out n minus w? N is 4 times 9.81 times m, and w is mg, m times 9.81. He is saying at the bottom, the normal reaction coming from the track should not be more than 4 times mg, 4 times the weight. So 4 times mg is this part, which is the normal reaction, minus the weight is mg, equal to the centripetal force, which is mv squared over rho. And that we know. Substituted those quantities and calculated what radius we should keep so that this experience, the force experience, will not be more than that. Now you tell me for what radius this will be more than 4 times mg. If we decrease the radius or increase the radius. Yes, because the net force equal to mv squared over rho for the same velocity. If rho decreases, it is in the denominator, and so the n value will increase. So as you are going through sharp corners with the less radius, you will experience more centripetal force. You need to experience, otherwise Just imagine you're sitting in the car with the same velocity, you go around a larger circle, and then you go around a sharp roundabout. So you'll be pushed against the side wall more when you are taking a shorter curve at the same velocity. I mean, curve with smaller radius. Any other question? This is a big problem, but what I suggest is I will read it and explain how it is to be done. You can try it at home. If you can't get it, I will solve it tomorrow in the class. The flying car is a ride with an amusement park which consists of a car having wheels that roll along a track mounted inside a rotating drum. By design, the car cannot fall off the track. However, motion of the car is developed by applying the car's brake, thereby gripping the car to the track and allowing it to move with a constant speed of the track, Vt equal to 3 meters per second. If the rider applies the brake when going from B to A and then releases it at the top of the drum A so that the car coasts freely down along the track B, determine the speed of the car at B and the normal reaction which the drum exerts on the car at B. Neglect friction during the motion from A to B. The rider and car have a total mass of 250 kilograms, and the center of mass of the car and the rider moves along a circular path having a radius of 8 meters. So it's a lot of description, but what it actually means is the guy will be hanging from the track at this place, and he is saying he has a velocity VA equal to 3 meters per second there. And from A to B, if you apply, and at the bottom, the free body diagram is something like this. Let's draw this for once in a reasonable quality level. So that is the free body diagram. The whole weight W acts down, the normal reaction acts upwards. This is at B. What is the velocity at B? To get that, apply the work energy equation from A to B, which gives half mass times VA squared plus, when it is falling from A to B, the gravity is doing work on that, which is mgh equal to half mass times the velocity at B squared. We can forget about this mass. Therefore, half times velocity at A is 3 meters per second plus 9.81 times the total height is 8 plus 8, 16 meters. Because radius is 8, it's falling through 2 radii. So that is equal to half velocity at B, we don't know, VB squared. From this, velocity at B is equal to 17.97 meter per second. Can you come back to this? Sigma F n equal to mass times centripetal acceleration. Let's write it reasonably. Sigma F n equal to mass times an. Therefore, n minus w equal to mass times VB squared over r. Therefore, n equal to w, which is 250 times 9.81 plus mass 250 times velocity of B, we know it already, divided by the radius is given as 8. From that, the normal reaction experienced by the passengers is 12.544 kilonewton. It's done. So if you have any questions, I will answer. If you don't have any questions, all right. If you don't have, you keep talking. In the meanwhile, I will save whatever is done and put it online.